Elon Musk has built a career around making bold promises that force entire industries to rethink what's possible. Whether it's reusable rockets, self-driving technology, humanoid robots, or electric vehicles, his announcements almost always spark one question: what happens if he actually succeeds? Now, imagine if Tesla revealed an entirely new type of electric motor so efficient, so powerful, and so inexpensive that it completely changes the economics of electric cars. Suddenly, everything from battery size to manufacturing costs, vehicle range, and even the future of traditional automakers would have to be reconsidered. While headlines often use phrases like "industry destroyed," the reality is usually more complex. Breakthrough technologies rarely eliminate competitors overnight. Instead, they redefine the standards everyone else must chase. And that's exactly why so many engineers, investors, and automakers are paying close attention to Tesla's relentless pursuit of next-generation motor technology. For years, Tesla has quietly been improving one component that receives far less attention than its batteries: the electric motor itself. Most people assume every EV motor is essentially the same, but that's far from the truth. Tiny improvements in efficiency can translate into dozens of extra miles of range, lower production costs, reduced charging times, and significantly higher performance. In an industry where every percentage point matters, those gains can be worth billions of dollars. Tesla's existing motors are already among the most efficient ever mass-produced. Their permanent magnet synchronous motors convert over 95% of electrical energy into motion under ideal operating conditions. That level of efficiency leaves very little room for improvement, making every additional percentage point increasingly difficult to achieve. Yet Tesla continues investing enormous resources into refining its motor technology. One of the company's biggest announcements came during Investor Day, when Tesla revealed its next-generation drive unit. At first glance, it didn't look revolutionary, but buried inside the engineering presentation were several developments that could reshape the future of EV manufacturing. The first surprise was Tesla's commitment to eliminating rare earth materials from future motor designs. Rare earth magnets, particularly neodymium, have long been considered essential for producing compact, high-performance electric motors. Nearly every major EV manufacturer relies on them because they deliver exceptional power density. The problem is that rare earth mining is expensive, environmentally damaging, and concentrated in a handful of countries. Supply chains remain vulnerable to geopolitical tensions, price fluctuations, and export restrictions. Every automaker knows this represents a significant long-term risk. Tesla's engineers decided to tackle the problem head-on. Instead of simply finding cheaper suppliers, they began redesigning the motor itself. The goal wasn't merely to reduce rare earth usage, but to eliminate it altogether while maintaining, or even improving, performance. That sounds almost impossible. Without powerful permanent magnets, traditional electric motors lose much of their efficiency and torque density. Competitors have attempted similar approaches, but most designs sacrifice performance, increase complexity, or require larger motors. Tesla believes it has found another path. Although the company has not publicly disclosed every engineering detail, experts believe the next-generation motor could rely on advanced reluctance motor principles combined with highly optimized rotor geometry, sophisticated power electronics, and improved inverter control algorithms. Rather than relying solely on magnetic attraction, these motors manipulate the natural tendency of magnetic fields to follow paths of least resistance. Sophisticated software constantly adjusts current flow thousands of times every second, extracting maximum efficiency from every rotation. The result could be a motor that's cheaper to manufacture, easier to scale, less dependent on global supply chains, and potentially even more durable over hundreds of thousands of miles. But that's only part of the story. Tesla isn't simply redesigning the motor. It's redesigning the entire manufacturing process surrounding it. One of Elon Musk's biggest competitive advantages has never been inventing new technologies first. Instead, Tesla repeatedly figures out how to manufacture existing technologies faster, cheaper, and at enormous scale. The company's gigafactories have become laboratories for manufacturing innovation. Massive casting machines replace hundreds of individual components with single aluminum structures. Automated production lines continuously evolve to eliminate unnecessary steps. Engineers regularly redesign parts, specifically to reduce manufacturing time rather than merely improve vehicle performance. The next-generation drive unit follows that same philosophy. Tesla claims the new platform could require dramatically fewer manufacturing steps while using significantly less silicon carbide in its power electronics. Silicon carbide chips improve efficiency but remain expensive. Reducing their usage lowers costs without necessarily sacrificing performance if paired with improved electrical architecture. Every dollar saved on each vehicle compounds across millions of cars. Imagine reducing production costs by even $500 per vehicle. Multiply that by 5 million cars annually. That's billions of dollars available for lower prices, higher profits, or increased investment in future technologies. This manufacturing obsession helps explain why Tesla often appears years ahead of competitors in cost efficiency. While many automakers focus primarily on designing impressive concept cars, Tesla designs factories capable of producing millions of affordable vehicles. And affordability may become the company's biggest weapon. Industry analysts believe Tesla's next-generation platform aims to produce vehicles costing roughly half as much to manufacture as today's Model 3 or Model Y. If successful, that could enable Tesla to introduce an affordable mass-market EV, priced around $25,000, or potentially even lower, depending on regional incentives. Such pricing would dramatically expand the addressable market. Millions of consumers who currently view EVs as too expensive could suddenly afford one. For competitors still struggling with thin profit margins, matching those prices would become extremely difficult. Some manufacturers already lose money on every electric vehicle they sell. Tesla, meanwhile, continues driving costs downward through vertical integration, software optimization, battery innovation, and manufacturing efficiency. Now imagine adding a cheaper, more efficient motor into that equation. The financial implications become enormous. Efficiency improvements don't simply increase driving range. They create cascading advantages throughout the entire vehicle. A more efficient motor consumes less electricity. That means the same battery delivers more miles. Alternatively, Tesla could install a smaller battery while maintaining identical range. Smaller batteries reduce weight. Lower weight improves acceleration. Reduced battery size lowers production costs. Fewer battery cells also reduce charging time because there's less energy to replenish. Every improvement reinforces another. This cascading effect explains why motor efficiency matters far more than most consumers realize. Tesla's engineering philosophy revolves around optimizing the entire system rather than maximizing individual components. It's not enough to build the world's best motor. It must work seamlessly with batteries, software, thermal management, power electronics, charging infrastructure, manufacturing processes, and autonomous driving hardware. Everything must function as one integrated ecosystem. That's an approach few automakers can easily replicate. Traditional manufacturers often purchase components from dozens of suppliers. Tesla increasingly designs everything internally: the battery, the motor, the inverter, the software, the AI computer, even much of the manufacturing equipment. That level of vertical integration allows Tesla to optimize interactions between components in ways competitors simply cannot. Software represents another enormous advantage. Modern electric motors aren't controlled mechanically. They're controlled digitally. Tesla's software continuously adjusts current delivery, regenerative braking, traction control, thermal management, and torque distribution hundreds of times every second. Even identical hardware can produce dramatically different performance depending on software optimization. That's why Tesla frequently delivers measurable efficiency improvements through over-the-air updates long after customers purchase their vehicles. Imagine buying a car that becomes more efficient months later without replacing a single physical component. That's already happened multiple times. Future motor designs could amplify this advantage even further. Artificial intelligence may eventually optimize motor behavior based on individual driving habits, weather conditions, terrain, battery health, and traffic patterns in real time. The motor effectively becomes smarter over its lifetime. Competitors are investing heavily in similar technologies, but Tesla's experience collecting billions of miles of driving data gives it an enormous software advantage. Still, it's important to recognize that Tesla isn't alone in pursuing next-generation motors. Companies across the industry are making remarkable advances. Manufacturers are experimenting with axial flux motors, carbon-wrapped rotors, advanced cooling systems, high-voltage architectures, silicon carbide electronics, and entirely new magnetic materials. Several startups claim significant improvements in power density. Others promise dramatically reduced manufacturing costs. The race remains highly competitive. Tesla's real advantage may not be inventing every breakthrough first. It may be commercializing them faster and producing them at scales nobody else can match. History suggests that's where Elon Musk excels. SpaceX wasn't the first company attempting reusable rockets. Tesla didn't invent lithium-ion batteries. The company didn't create electric vehicles. Instead, it repeatedly refined existing technologies until they became commercially dominant. That pattern could repeat with motors. If Tesla successfully eliminates rare earth materials, lowers manufacturing costs, maintains world-class efficiency, and scales production into the millions, the competitive landscape could shift dramatically. Automakers unable to reduce costs may find themselves struggling to compete on price. Battery suppliers may need fewer cells per vehicle as efficiency improves. Mining companies focused on rare earth elements could experience reduced demand from parts of the automotive sector. Consumers would benefit from lower prices, longer range, and potentially faster charging. Entire supply chains would evolve around these new engineering priorities. Of course, bold engineering ambitions don't always translate into immediate success. Mass production presents challenges that laboratory prototypes never encounter. Manufacturing tolerances, durability, supplier availability, quality control, regulatory approval, and economic conditions all influence whether revolutionary technology actually reaches customers. Tesla itself has experienced production delays before. Promises often arrive years before products. That's the nature of ambitious engineering. Still, one fact remains undeniable. Tesla continues investing aggressively in motor technology because Elon Musk understands a simple truth that many people overlook. The future of electric vehicles won't be won solely by bigger batteries. It will be won through relentless efficiency improvements across every component inside the vehicle. Every gram saved, every watt conserved, every manufacturing step eliminated, every software optimization discovered. Together, those incremental gains become revolutionary. So, will Elon Musk's new engine destroy the entire EV industry? Probably not in the literal sense. What it could destroy is complacency. It could force every automaker to rethink how electric motors are designed, manufactured, and integrated into future vehicles. Those unable to keep pace may lose market share, while those that adapt will push the industry forward even faster. In the end, the biggest winner wouldn't be Tesla alone, it would be consumers. Better motors mean cheaper EVs, longer driving ranges, faster charging, lower operating costs, and more sustainable transportation. If Tesla's next-generation drive unit delivers on even a portion of its promises, it won't end the EV industry. It will raise the bar for everyone in it, accelerating the transition toward a future where electric vehicles become not just an alternative to gasoline cars, but the obvious choice.